Hello and welcome to the YouTube channel D Creations Resources. We are solving multiple choice questions for physics, maths, general aptitude, etc. We have been solving questions for exams at different levels, including exams like Homi Bhabha at school level, then exams such as NEET, IIT JAM, etc. and even exams from higher education such that NET, SET, JEST, etc. Today we will solve a question from the CSIR NET exam, and the question is from the question paper of June 2014. It deals with experimental methods and basically electronics. The question is an opamp based voltage follower, and the options are A is useful for converting a low impedance source into a high impedance source. B is useful for converting a high impedance source into a low impedance source. C has infinitely high closed loop in output impedance, and D has infinitely high closed loop gain. Now let's first look at the explanation and then we go to the answer. So here opamp, as you know, is an operational amplifier and it has certain characteristics, but here we are looking at opamp in the voltage follower mode. So it's an amplifier, and usually an opamp, an ideal opamp, has infinite gain, but a voltage follower, you can see that there are no resistances here, and it's a unity gain amplifier. So there are different names for it. It's called a buffer amplifier, an isolation amplifier, etc. So here the voltage gain is 1. That means whatever is the input, same thing is going to be the output. So it does not provide any kind of an amplification or attenuation basically. The gain is 1, and as I mentioned, input and output are equal. So in other terms, you can say the output voltage is directly following the input voltage, and that's why it's called a voltage follower. And here amongst the options, the correct option is B, that a voltage follower basically is useful for converting a high impedance source into a low impedance source. And of course, I'm sure when I say impedance and when you think of Ohm's law, it also talks a lot about the current. So this is the answer for the question on voltage follower. Thanks.